Hey guys, Mrs. Saller here. I just wanted to give you guys an overview of this ellipse thing because I was out today and I feel a little bit nervous about leaving you without any help from the sub. So anyways, today you should have been learning about ellipses, which are kind of the close cousin of the circle. And they have a lot of the same features, but some, pretty big differences between them as well. Now, one thing you're going to notice about this that's the same between all of these is that the center is that H and K. So with both this horizontal ellipse and vertical ellipse, the center will always just be your HK. And then I'll give you the exact center of the ellipse. So like in this one, it'd be right about there. There would be your HK, and this one, that got kind of cut off, would be about HK as well. Now the thing that makes this ellipse different than a circle is that the radii are different, and these A and B values tell you which one is your big radius and which one's your little radius. So first of all, the A value is always your big radius, which we call the major radius. And so when it's underneath the x's, you'll have a horizontally long ellipse. So this and this will be your A values. So that's when it's underneath the x's, you have a long ellipse horizontally. And if it's underneath the y's, that major radius, then it's going to be going vertically long. So this will be A and this will be A this way. The B is the minor axis, and that's the smaller, the minor radius, which is the smaller of the two radii. So whatever number is underneath the smaller radius, or underneath the y or x, is going to give you the smaller radius. So in our horizontally long ellipse, our vertical is going to be the smaller radius, so that'll be B and that'll be B. And likewise, in our vertically long ellipse, the smaller radius will go horizontal. So that'll be B and that'll be B. Now notice that both these equations are equal to 1. That's important. If you're not equal to 1, you need to get it equal to 1 first. And probably the only thing we really need to talk about is this idea of focal points. Now focal points will always be on the major axis. So focal points are always on the major axis. And they basically tell us how skinny or fat our ellipses are. The farther the focal points are away from the center, the skinnier it's going to be. The closer they are to the center, the fatter your ellipse is going to be. So the more circular your ellipse is going to be if they're closer to the center. And that focal point, that C value that you should have seen in the notes, that C value gives you your focal distance from the center. And again, that'll always be on the major axis, and if you go C, in this case, left over here, so C units left, and C units right, that'll give you where your focal points are. And because this is kind of a skinny ellipse, they'll probably be farther away from the center. And likewise, this one, because it's going to be on the major axis, you go up C, that distance C, and down C, and that'll give you your focal points there. And those, again, just help us figure out how skinny or fat our ellipse is. Now the most important thing is how to find C. The way you find C is you do C squared is A squared minus B squared. So C squared will be equal to your major radius squared minus your minor radius squared. And that's kind of the big formula of the day. So you need to have that memorized because you're going to be finding focal points and you need to be able to do that with that. So those are kind of the big things. So let's take a look at a couple examples. I'm just going to do two with you guys so you can see how they're done. So let's take a look at C, and you can get the rest of the notes from the notes you got from the sub today. So taking a look at C, we have x squared over 16 plus y squared over 4 equals 1. Definitely ellipse standard form that we talked about on the other page. So the first thing I'm going to do is I'm going to find the center, which in this case we have no h and k, so it'll be 0, 0. So let's plot our center at 0, 0. Now this time it's going to be a horizontally long ellipse because your bigger radius is underneath the x. So our a squared is equal to 16 and our a is equal to 4, and that's going to go side to side. So we're going to go right 4 and left 4, and that's going to give us what's called the major axis. So that gives us our big long part of our ellipse. Now the b squared term is going with the y, and so the b squared is equal to 4. And so our b is equal to 2. So our minor radius is going with the y, so we'll go up 2 and down 2, and that gives us enough to graph our ellipse. So when you connect all those to make your ellipse shape, it should look something like this. Now they're going to want you to list the endpoints of the major and minor axes, as well as the corners to the center and the foci. We already did the center. Now the major axis, which is just where your major radii are, is going between 4, 0. So write these as coordinates, so 4, 0 and negative 4, 0. And your minor axis is going from 0, 2 to 0, negative 2. Okay. Now the only thing you have to find is where your focal points are. Okay, so we're going to use that little new formula, c squared is a squared minus b squared, and plug into that to solve for c. So c squared is going to equal a squared is 16 minus b squared is 4. So you get c squared is equal to 12. So c is equal to root 12, which is 2 root 3. Now for graphing purposes, you know that's going to be about, it's going to be a little bit bigger than 3. So let's go right 3 and left 3, and that gives you where your focal points are. Okay, a little bit more than 3, a little bit less than 3. And again, always on the major axis. It shouldn't, your focal points shouldn't be outside the shape. They should be inside the shape, so they're going to have to be on the major axis. So now we need to write those points. Okay, so this guy moved right 2 root 3 to get there, and this guy moved left 2 root 3 to get there. But the y-coordinate's still just 0. So for our focal points, which we write foci when we're doing plural of that, you get 2 root 3, 0 for your 1, and the other guy is at negative 2 root 3, 0. Okay, so you're basically just taking plus or minus your c value when the center is at 0, 0. Okay, so that's how you do one where your center is at 0, 0. It gets a little bit trickier when your center is somewhere else. So let's take a look at h. Now in h, you're going to have to do something first, because remember we talked about that standard form on the previous page. You need to be equal to 1 over here. So the first thing we need to do is we need to divide through by 16 to get that right-hand side equal to 1. And so now it is equal to 1. But now simplify this. 4 over 16, you can reduce that to x minus 2 squared over 4. And this guy you really can't do anything with, so leave him as y plus 3 squared all over 16. Now this looks just like the standard form. So first I see my center is at the point 2, negative 3. So we're going to go to 2, negative 3 and put our center. And now this is going to be a vertically long ellipse, because notice the bigger number is with the y's. So we're going to have our a squared number is 16, and our a is 4, but this time it's going to go vertically. So we're going to go up 4 from the center, and down 4 from the center to get our vertically long major axis. The b squared number, the smaller number, is going with the x. So we know that b squared is going to be equal to 4, so b is equal to 2, and this is going to go right and left. So you're going to go right 2 and left 2, and there is your ellipse when you connect all those. Okay, now notice that we have to still give our major axis, so give the endpoints the major axis. You get that this one up here is at 2, 1, and this one down here is at 2, negative 7. For your minor axis, you're at the points, let's see, 0, negative 3, and at the point 4, negative 3. Okay, so that's the graphing portion of it. Now we need to find the focal points. So you're going to do the c squared is a squared minus b squared formula. Find your focal distance. Remember, it's going to be on the major axis, so we'll add that onto our major axis. So we get c squared is equal to, well, a squared is 16 minus b squared is 4. So we get c squared is 12. And so we get the same focal points we did in the last one, but obviously a different shape. But this is going to be 2 root 3, which is again 3 point something. So we'll go up 3 point something. There's one focal point and down. So the big difference from the last one, even though the focal points are the same, we're going up and down because we need to make sure we're staying on the major axis of those focal points. So now this is where it gets tricky. We want to write what that point is, but we don't want to write it as a decimal. So notice that we went up 2 root 3 and we went down 2 root 3. So to get the first focal point for our foci, notice the x-coordinate's still 2. But we went from negative 3 up 2 root 3. So we're going to take negative 3 plus 2 root 3 to get the 1 coordinate, the y coordinate. And the other guy, we're still at x equals 2, but now we're going from negative 3 down 2 root 3. So it's going to go negative 3 minus 2 root 3, and you got your focal points taken care of. Alright, so hopefully this quick little crash course will help you guys get through the homework, and then look back at the printed out notes that you got from the sub that you should have copied down. And hopefully this gives you enough to kind of make it through tonight's homework, which you should have received. And feel free to drop by. I am actually here after school on Monday, and I'll be here before and after school Tuesday, so drop by if you're having trouble with this, because we are going to move on and continue on with ellipses on Tuesday. Alright, so hope this helps, and I'll see you guys tomorrow.